Good day, everyone. Today we're going to discuss about powers and exponent. This this one is in chapter 2.7 of our lesson. Okay. So multiplication, which is a shortcut of addition. When you need to add the same number to itself over and over, multiplication is a shortcut way to write. We have the addition problem. Instead of adding 2 plus 2 plus 2 plus 2 plus 2 equals 10, we can write as 2 times 5 and get the answer equals to 10. So powers is a shortcut of multiplication. So when you need to multiply the same numbers by itself over and over again, powers or exponent are the shortcut way to write the multiplication problem. Instead of multiplying 2 times 2 times 2 times 2 times 2, that will give you 32. You can write as well 2 times or 2 raised to the power of 5 and get the same answer as we have 32. So if you're going to multiply the same numbers, we can use the powers or the exponent to make it as a shortcut way. It will give us now 2 to the power of 5. So the power, a number written as the base number with an exponent. So base and the exponent. So like this one, right? So we have the base, which is the 2, and then the exponent is 5, or the power. You can say that 2 to the power, or the fifth power, 2 to the power of 5, or 2 to the fifth power, or 2 fifth. Okay? 2 raised to fifth, or raised to 5. It's the same. We have orders. So the base, big number of the bottom, the repeated factor in a multiplication problem is that we have now the exponent. So we have now factor times the factor, so we can get the product, right? So therefore, we have now base raised to the exponent equals to the product of the multiplication. So the exponent, okay, the exponent now, little number on the top right of the base, the number of the times that the base is multiplied by itself. So we can give now as 2 to the power of 5 because we multiply the 2 here 5th time, right? Therefore, 2 times 2, 4 times 2, 8 times 2, 16 times 2, we get 32. Therefore, we will have now equals to, we have here 2 times 2 times 2 times 2 equals to 32. So it says now, ordinal numbers can be first, second, third, fourth, fifth, and so on and so forth. So whatever the exponent there, you can write it as possible. So you can have 2 to the power of 6, 2 to the power of 7, 2 squared, 2 cubed, and then after that you just multiply it the same. Whatever the exponent, that will be the factor of the base. So for example, it is 5 here, so you multiply 2 into 5 times. If it is 6, you multiply 2 in 6 times. So 2 to the power of 2 or 2 squared, say 2 to the power or second power of or 2 squared. So you can use this one as 2 times 2 equals to 4. And then we have 2 cubed, or we say this one as 2 to the third power or 2 raised to the power of 3. Okay, so you can have different, there are a lot of different ways to say we have 2 cubed, 2 raised to the power of 3, or 2/3, or you can add 2/3 is different. 2/3 is we have 2 over 3. We have here as 2 to the third power, okay, which says now 2 cubed. Okay, so we say now we have 2 times 2 times 2, which is equals to 8. So it's not equal to say that 2 to the power of 5 is not equal to say that this is 2 times 5, because you're going to do is 2 times 2, you're going to multiply 5 times. So 2 raised to the power of 5 is not equal to 10. The same as negative 2 to the power of 4 does not equal to, open and close parentheses, negative 2 to the power of 4, because here you multiply first the 2 and then multiply to the sign. And then on the other side, you multiply together with the sign. So which gives us, without the parentheses, positive 2 is multiplied by itself 4 times. Then the answer is negative. With the parentheses, negative 2 is multiplied by itself 4 times. Then the answer becomes positive. So here the answer will become negative. The other one, the answer will become positive. Because here, just always remember, if it is not inside the parentheses, you will not include the negative sign here, the sign to multiply by itself. So 2 to the power, or negative 2 to the power of 4 is equals to negative 1 times the value of x, which is equals to negative 16. That is the reason why it is not equal to, we have inside of the parentheses, okay, inside of the parentheses, raised to the power of 4. Okay, when the exponent is 0, so we all know that any variable raised to 0 is equals to 0, right? Therefore, 2 raised to 0 is equals to 1. 4,638 is equals to 1 raised to 0 is equals to 1. So any number except 0 is equal to 1. So if the exponent is 1, it will remain the same. So 2 raised to the power of 2 still remain the same. So the exponent 1 is usually, we don't put that 1 there, right? So we just write 2 and then we just write 468. So the same. Any variable and any number without exponent that is understood that it has, we have 1 exponent. So again, to write the product or to write a product as a power as a product, so power, write the shortcut way to, we have 2 to the power of 5. It means that you will have 2 times 2 times 2 times 2. Okay, so whatever the exponent there, that is the time that you're going to multiply we have the base. Okay, now let's go to the next one, which is the scientific notation. Scientific notation. So if the factor is greater than or equal to 1 and less than 10, the second factor is a power of 10. So that is a scientific notation. So there are numbers that are we have longer to write, right? If the number now can be, if the number will be shortened, it can be written in scientific notation. So for example, we will have 1, okay, 1 times 10 to the power of 8. We can have 3 times, or 3.8 times 10 to the power of 3, or cube. So these numbers are, we have big numbers, and then we shorten it in the form of scientific notation. So for example, how we will simplify numbers with scientific notation. So let's say we have 1,300. Write it in scientific notation. So what you're going to do is, if you're going to move, okay, if you're going to move the decimal place going to from right, okay, from right to left, the exponent will become positive. So therefore, we move this one from 1 to 3. So you will write now 1.3 times 10 to the power of, how many times? 1, 2, 3 to the power of 3. So it means that when you are going to move the decimal place to the right, okay, to the left, I mean, going to this way, it will give you a positive, okay, it will give you a positive exponent. Positive exponent. And then if you are going to move, for example, we have 0.0053. If you are going to move the decimal place going from left to right, the exponent now will give you we have negative exponents, okay? So therefore, this one now will be simplified as, we have moved, the point is here, so you move 1, 2, 3. So we have now 5.3 times 10 to the negative 3. So here, remember that this value, it says in our definition that A must be equal, or this one, the first one, will be equal to 1 or greater than 1 but less than 10. So therefore, the value here, for example, we have in the form of A times 10 to the power of n. So A now, A must be less than, okay? Must be less than 10 but greater than 1 or equal to 1, okay? So therefore, A must be greater than or equal to 1 but less than 10. N is the factor where how many decimal places we're going to move. So let's try some example. Let's say we have, for example, let's say this one, 135 million. Okay, 135 million. Try to write this one in we have in a scientific notation. So therefore, we will have now as we have 1.35 because we need this one as greater than 1 or equal to 1. How many decimal places? We have 1, 2, 3, 4, 5, 6, 7, 8. Therefore, that is times 10 to the power of 8. So that is how you will solve for scientific notation. Okay, for example, we have, let's say we have 0.000015. Okay, how will we write this one? So the point is here. The decimal is in the decimal place. So the answer now will give us 1.5 times 10. How many times we move the decimal place? So we have 1, okay, 1, 2, 3, 4, and 5. So therefore, it will give us negative 5. Again, if we're going to the left, okay, from right to left, it will give us a positive. But if it is left going to right, it will give us, we have negative result for the exponent. Okay, so that is how you will solve now for the exponent. But let's try. What if we will convert, we'll try to convert now scientific notation to, we have real numbers. So for example, we have, let's say 3.2 times 10 to the power of 5. So therefore, you will have now 3.2, okay, 0.2. How many decimal places? So you will have to move 5. So you will get now 1, 2, 3, 4, and 5. So you will put zeros here. 1, 2, 3, and 4. So therefore, 3.2 times 10 to the power of 5 is equal to 320, we have 1,000. Okay, so we get now as 4 zeros here. So therefore, you will have now 320,000. Let's say we have 1.3 times 10 to the power of negative, let's say negative 4. Okay, so therefore you will have now, you will try to move now the decimal place going to, we have left because it is negative. So therefore we will have now as, let's say we have 1.3, right? So you move how many? 4 times. So you have 1, 2, 3, and 4. Therefore the point will be here, 0.1, 2, and then 3. So therefore your answer now will be 0.00013. So that is your solution. Okay, so in solving again scientific notation, you have to check the correct way of we have exponents. Okay, that's all for your lesson for today. Just wait for the announcement for your classwork. Have a nice day to everyone, and God bless.